Now we're going to look at two different ways to write domain and range. So the first way is set builder notation, and that is a set of numbers indicated by braces, so you use little curly brackets, along with the symbol this, which is like a straight line, meaning such that, and then the symbol, it kind of looks like an E, is read is an element of. And the other type of notation is called interval notation, and that describes a set of numbers using the endpoints with parentheses or brackets. Parentheses, which are the rounded ones, indicate that the endpoint is not included, and brackets, that are the square ones, indicate that the endpoint is included. Okay, so it's good to know both types. Eventually, you'll be able to just use one of them. You don't necessarily have to use both every time that you're stating the domain and range. But for now, if you're asked to use a certain one, I want to make sure that you understand which one is which. So here's a couple of examples. So let's say the algebraic notation is x is greater than -1. So in set builder notation, we would say x such that x is greater than -1, and they're included in those curly braces. Okay. In interval notation, because there's no line underneath the inequality symbol, we know that it does not include -1. So we have a parenthesis, a -1, and then comma infinity. That means that it's from -1 and everything to the right of that on the number line, or everything greater than -1. And infinity is always going to be using parentheses since it's more of like an idea and you can't actually reach it since it's not a number. So it will never include infinity. Okay, here we have all real numbers. So all real numbers in set builder notation, we would say x such that x is an element of all real numbers. And in interval notation, we would say -infinity to infinity. And again, both open parentheses since it can't include infinity. If you have something between -3 is less than x is less than or equal to 10, again, set builder notation, we're saying x such that, and then we can just use this notation here. -3 is less than less than x, which is less than or equal to 10. The interval notation, we can see it's between -3 and 10. There's no line underneath the inequality symbol here, so we'll have a parenthesis in front of the -3. And then the 10 does have a line underneath, including the 10, so we are going to use one of those square brackets on the 10. Okay, and the last example, x is less than or equal to 0. So set builder notation would be x such that x is less than or equal to 0. And the interval notation would be -infinity, comma 0. Notice that -infinity does have a parenthesis and that the 0 does have a bracket. Okay, it's including 0, so we have that bracket there. Okay, since it's everything less than 0, we're taking everything negative up until 0. Okay, so let's look at some examples here. So first we want to figure out, does this graph represent a function? And then give a domain and range in both set and interval notation. So first thing we do is check if this is a function. So notice it's asking about just this graph. Is it a function? So we can do the vertical line test. So if I draw vertical lines at different points, okay, it's only ever touching the graph at most once. So we know that this is a function. So I'm just going to, erase this so it doesn't confuse us. So we do know that it is a function. So yes, it's a function. And then what we're going to do now is find the domain and the range. So domain are the x values. So let's find set notation first. So this is that set builder. Okay, so in the domain, our set builder notation, we're always going to start with that curly brace, and since domain is x, we're going to say x such that, and then we have to figure out what the domain actually is. So remember, we're looking at the x values, and we want to look left to right. So since I have arrows on both ends, that means that that's continuing on forever. So every x value to the left and every x value to the right will be part of this graph. So that means that it would be all real numbers. So we're going to say x such that x is an element of all real numbers. Okay, so that's our set builder notation. If I were to write this now in interval notation, okay, since all real numbers is going from negative infinity to positive infinity, we know that we cannot include infinity, so we're going to have a parenthesis, negative infinity, comma, infinity, close that parenthesis. So that is for our domain. Now for the range, we're looking at the y values. So again, let's start with set builder notation. When we look at the y values, again, we can see the arrows pointing down. That means they're going to go down forever. And we can see that the graph is stopping at 2. Right? There's nothing from our graph that's above this line of 2 for y. So our set notation, again, we're still going to use those curly braces, and we're going to say in this case y, since range is y, such that y is less than or equal to 2, and then close our curly braces. Right? This is showing us that it doesn't go above 2, so everything from 2 and below. In interval notation, okay, we always want to go from low to high. So the lowest y value that we possibly have is negative infinity, since our arrows are pointing down forever. So we'll say it goes from negative infinity, comma, the highest y that it's going to touch is 2. Okay, and it is going to include 2, since we don't see any open circles on our graph, and here we did include it in the set notation, so we are going to include the 2, so we have a square bracket. Okay, now let's look at another example. Okay, first we check, is it a function? If we draw vertical lines through this, we will see that it is a function, so I'm just going to say up here, yes. Okay, and just like before, we're going to do domain and range. So domain, first I'm going to do it in set notation. So I'm always going to start set notation with x such that. So we look to see what the x is doing. Again, we have arrows on both ends, so the x's are going to the left forever and to the right forever. So again, that would be all real numbers. So x is an element of all real numbers. And then we have those curly braces. And then our interval notation, similar to the previous problem, is going to be negative infinity to infinity. Okay, and then we're going to look at the range. And again, here for range, we're looking at the y values. So we can see that the lowest y value is -5, and then it continues up forever. So our set notation would be y such that y is greater than or equal to -5. And our interval notation, again, we're always starting from the bottom. So the bottom is -5, and it does include it. So we're going to use a square bracket, -5, comma. The highest y value, it goes on forever, so that would be infinity. And we're going to use a parenthesis. Okay, let's look at another one. So again, is it a function? I can check by the vertical line test. Yes, it is a function. First, we'll find the domain. So this looks very similar to the one we just did. It just kind of reflected a little bit over the x-axis. So our set builder notation, it includes every x value. So x such that x is an element of all real numbers. And interval notation. So with interval notation, again, similar to the problem before, we are going to just have parenthesis, negative infinity to positive infinity. For the range, we are going to look at the y values, and we can see here that the highest y value we get to on this graph is 1, and everything else is below that. So for our set builder notation, we're going to say y such that y is less than or equal to 1. And then for our interval notation, remember that we are going from the bottom to the top, so the lowest y value we have would be negative infinity, and it goes up to positive 1, and it does include 1, so we're going to have a square bracket. Okay, and the last example here, if I were to use the vertical line test and draw through here, I can see this fails the vertical line test because it crosses more than once. So is it a function? No, it's not. Just erase that. And then again, let's look for our domain and our range. So domain, again, our x values. So let's do this in set builder notation. So we're going to say it is x such that, so let's look at our graph. The farthest left that we have is -4. The farthest right that we have is 3. So the x's are between -4 and 3. And if you notice, at -4, it does include it because we have a closed circle. At 3, we have an open circle, so it does not include 3. So we're going to say it's x such that -4 is less than or equal to x, which is less than 3. So we're going left to right with our x's. In interval notation, again, we're going left to right. The farthest left x that we have is that -4. It does include that, so square bracket -4, comma, 3 is where we're ending, but we don't include 3 because we have an open circle, so parenthesis at 3. Okay, and then for the range, we're going to look to see what our y's are between. We can see our lowest y is -5, our highest y is +5. So in set builder notation, we're going to say it's y such that, and then we're going to go from -5 is less than, it does not include -5 because we have that open circle, so just less than y. And then at 5, again, we have an open circle, so it's not going to include that either. So less than 5. And then in interval notation, we have between -5 and 5. They are both not included, so we're going to use parentheses. -5 to 5, close those parentheses.